right, guys, we're on the back side of Unit 5, Day 13 notes, talking about average rate of change. And in number 4, it says that the population of a large town in upstate New York was 19,413 people in the year 2015. It says that the population is increasing according to the following formula, where P is the population of the town T years after 2015. What was the average rate of change? So right there it tells me I'm using my y2 minus y1 over x2 minus x1 formula in the population from 2015 to 2020 to the nearest whole number. Use appropriate units to label your answer. Okay, so they gave me my two x values. It's 2015 and 2020. Okay, and so we need to go and figure out the y values that go with it. Nice thing is they gave me a formula that I can go ahead and plug into my y equals in my calculator. Okay. However, you had to watch out for one tiny little thing in that T is the number of years after 2015. Okay, so since one of our x values is 2015, okay, and T is the number of years after 2015, we have an x value of 0 comma something, okay? 2020 is 5 years after 2015, and so our x value is going to be 5. Hopefully that makes sense. A little bit tricky, okay? So now when we go and we type our equation into y equals, and we go to our table, we're looking for an x value of 0 and an x value of 5 and looking for the y values that go with them, okay? And hopefully you find them. Paired with 0 is 19,413. Oops. Okay. And paired with 5 is 43,921. Okay, now that we have our two x values and our two y values, now we can go ahead and plug them into our formula, okay? I'm going to go ahead and choose to do the 43,000 y value first, minus my other y value. Because I chose to put 43,921 first for my y, I'm going to have to put 5 first for my x, and then minus 0. Okay? If I clean up the top, it ends up being 24,508. Divided by 5 minus 0, which is 5. Go ahead and divide them, and we end up with 4,902. If I go back and think of what my label would have been, my y value is my p, and my p is my population. All right, so this would be people. On the bottom, my x values are the number of years. Okay, so this will be years. And so we're going to go ahead and give our number of 4,902 a label of people per year. And that one's done. Okay, number 5, it says that the function n of t, which is equal to, models the number of grams in a sample of cesium 137 that remains after t years. On which interval is the sample's average rate of decay the fastest? Okay, so average rate of change, average rate of decay, average rate of growth. That average rate makes it a y2 minus y1 over x2 minus x1 problem. Okay, it's just that I'm going to assume, since they're saying average rate of decay, that our average rate of change will come out to be negative. Okay? And they want to know which one is the fastest or the greatest. Okay, so we have a lot to figure out. So first off, we're going to go ahead and put the formula in our y equals. Okay. And in this one, guys, remember that these are both of our x values. Okay. And so in this first one, guys, we have 1 comma and 10 comma. Okay. In this one, we have 10 comma, so we can use the same value there, and 20 comma. Okay. In the choice 3, we have 15 and 25. Those are our two x values. Okay. And in number 4, we have 1, and 30. All right, so we'll put this into y equals, and then we're going to go to our table and we're going to go ahead and match it up to our values for our x and our y. Okay. 1 is going to be paired with 97.726. Okay. 10 is going to get paired with 79.453. Okay. Again, 10 is going to be paired with 79.453. 20 is going to get paired with 63.128. In choice 3, 15 is going to get paired with 70.822. 25 is going to get paired with 56.27. 1 is going to get paired with 97.726 again. And 30 is going to get paired with 50.158. All right, so now each choice has their 2 x's and their 2 y's, and now we can go ahead and compute our average rate of change. All right, so since we have to do each one so that we compare all of them, it's going to take a little bit of time, but we'll give it our best shot. All right, so here's choice 1. Choice 1 would be our y value subtracted on top. So I'll label this as choice 1. So 97.726 minus 79.453 over our change in x values, which would be 1 first, and then minus 10. Okay. If we figure out what this is, figure out the top, divided by -9, and we're going to end up with -2.03. Okay. No clue if that's the answer because I don't have anything to compare it to. So in choice number 2, again, we're going to go ahead and take our y values and subtract them. So I'm going to do 63.128 minus my y value of 79.453. All divided by, because I did 63 first, I have to do 20 minus 10 on the bottom. Okay. Clean up the top, clean up the bottom, and then divide. And when you're done, we should end up with negative 1.6325. All right, choice number 3. I'm going to go ahead and put the 70 first, 70.822 minus my y value of 56.27. Okay. Because I put the 70 first, I have to put the 15 first, then the minus 25. Clean up the top, clean up the bottom, then divide, and we should end up with negative 1.45. Okay. We have one more to do, which is number 4. Okay. And I'm going to put the 97.726 first, minus my other y value of 50.158. And because I put the 97 first, I have to put the 1 first, minus 30. Okay, clean up the top, clean up the bottom, then divide, and we end up with negative 1.64. All right, so now taking a look at all of my rates of changes. Okay. Notice they're all negative, which is why they're saying decay, all right? And so now we're looking for the greatest number. And it seems to me that the greatest number is the very first one, negative 2.03. And so we're going to go ahead and say over this interval, we are decaying on average the fastest, okay? All right, so a tough multiple choice question, although you're doing the same thing over and over again for each choice, still kind of a little bit on the tedious side. Okay. All right, number 6. So it says that the distance needed to stop a car after applying the brakes varies directly with the square of the car's speed. The table below shows stopping distances for various speeds. And it says determine the average rate of change in braking distance in feet per miles per hour between one car traveling at 50 miles per hour and one traveling at 70 miles per hour. Explain what this rate of change means, okay, as it relates to the braking distance. Okay, so again, they said average rate of change. That's how I know I'm using my formula. They gave me my 2 x values of 50 and 70. Okay, I'm going to go find those in my table so I know what they're paired with. Okay, and then we can go ahead and throw them into our average rate of change / slope formula. Oops. Okay, and so we're going to go ahead and take my y value of 306.25, subtract my y value of 156.25, divided by 70 minus 50. Okay. We clean up the top, clean up the bottom, okay, and then divide, and we should end up with 7.5 feet per mile per hour. Okay, so again, these are in feet here for your y values. And on the bottom are our x values, which is our speed or our miles per hour. And so that's how I came up with the label of feet per miles per hour. Okay. However, they wanted us to explain. And so we have to write a sentence at least. All right. So we're going to go ahead and say between 50 miles per hour and 70 miles per hour, there is an average, and because our 7.5 came out positive, an average increase in braking distance of 7.5 feet for every 1 more mile per hour over 50 the car travels. Okay, and that one's done. All right, we got one more question to go. In number 7, it says that the table shows the number of daylight on the first day of each month in Rochester, New York. Given the data, what is the average rate of change of daylight per month from January 1st to April 1st? Interpret what this means in the context of the problem. Okay, so here's January 1st. Here's April 1st. Okay, we're going to go ahead and use 1 for our month of January, 2 for February, 3 for March, 4 for April. Okay, and so we're going to go ahead and subtract our, well, let's write this out first. We have 1 comma 9.4 and 4 comma 13.9. Now we can go ahead and subtract our y values. So 13.9 minus 9.4 divided by 4 minus 1. Clean up the top, clean up the bottom. Okay. And then go ahead and divide, and we get 1.5. Okay. Remember on the top, those numbers, 13.9 and 9.4, were hours of daylight. On the bottom, 4 minus 1 is the months. All right, so when I put a label on here, it's 1.5 hours of daylight per month. Okay, except they asked us to interpret, so we have to go ahead and write a sentence or two out. And so we're going to go ahead and start off with what we always start off with, which is between. And then we say between the two x values that they gave us, which was January 1st and April 1st. Then we say there is an average. And because our 1.5 that we came up with is positive, we're going to say an average increase of 1.5 hours of daylight per month. And there we go. All right. So hopefully that helps with the average rate of change. It's not that bad, especially since you should already be familiar with the formula. Just remember, they always give you your 2 x values. It's your job to go find out the y values, whether it's from a table, from an equation, from a graph. All right. And then once you find your 2 points, plug them in, and just be careful if they want you to label. Hopefully it makes sense how I came up with my label when I go back and think about what the y's are actually labeled in and the x's are labeled in, and then you divide them so you say per. All right. And then if they ask you to explain, make sure you explain specifically. Okay. All right, guys. Hopefully that helps, and I'll see you guys later.